Okay, so this is Public Lab's call on community science and soil contamination. We've just spent a few months reviewing and refreshing materials on soil pollution on the Public Lab website, including information on soil testing methods and remediation. So we're here on this call to share some of the highlights from that collaborative work and talk about just getting started with investigating soil pollution in communities. So we'll have time in the latter half of the call to reflect and share on some of the things that come up today. I'm just going to paste the welcome in the chat so people can read if that's more helpful. So if you'd like to introduce yourself in the chat, please go ahead, please share your name and where you're calling from and anything about what you're looking forward to hearing about or learning today. So my name is Jeanette Lim. I am the research coordinator at Public Lab, and I'm calling from Bellingham, Washington in the United States. And I'm really excited to share what we've been learning over the last few months about soil contamination, and also hear about what other folks have been working on and thinking about in their communities as well. So thanks everyone for joining us today. And I will just paste this note in the chat too for folks who are joining if they want to introduce themselves. Okay. So just to set some context here, I'm going to share my screen for a bit of a presentation. I'll show some slides, and then we'll have a couple times during that presentation to just pause and think along the way before the more dedicated reflection time at the end of the session. So I'm going to share my screen now. Oops. Here, we'll do it. Okay, can folks see the title slide there? Wonderful. Okay. Okay, so digging into soil research, the state of community science on soil contamination. So I wanted to start with a group question that we can enter our answers into the chat. So what do you think of when you hear the term soil contamination? So what comes up for you? What thoughts, questions? Just please feel free to put your reactions in the chat, and we'll just take a minute to think of that and then enter our thoughts there. Thanks all for sharing your thoughts about soil contamination and also your introductions. Please keep entering in the chat there as we keep talking. But I'm seeing heavy metals and lead in particular come up a lot. Health hazards, waste. So these are a lot of the terms that came up as we were doing this review on soil contamination as well. Heavy metals were at the top of the list. Also pesticides, industrial facilities nearby. So people worried about what sort of spill there might be coming over from nearby areas around lead, especially old houses and lead paint, lead gasoline from highways and roadways, even though leaded gasoline is not available anymore. There are things that have landed in the soil and stayed there over time. And then also questions about, is it safe to garden and to grow food and eat that food that I grow? Is it safe for my kids to play? And is it safe for my pets to be in the yard? Also health issues and risks that come out of being near potentially polluted soil. And then accountability. So who is in charge of cleaning up polluted soils and what remediation methods are out there? So those are just some of the things that came up as we were working on this review. These are some of the things we'll also touch on today. One really common question that came up from folks who are interested in soil pollution is really just finding out like what is in the soil and do I need to worry about it? So for the public lab researcher review, what we want to do is sort of get at one way of starting to answer some of these questions is by using observation and accessible tools to investigate the land and the soil. So residents, communities, organizations, many of you folks on this call have been doing this all over the world already, asking questions about what's in the soil and using and creating scientific tools to help them find answers. Over the last few months, at Public Lab, we've been collaboratively searching for these approaches and tools that are out there to do community science on soil contamination. And some of the folks who are working on using and advancing these tools as well. So we used the Public Lab website and our weekly open calls that are drop-in calls to ask and answer questions of each other, and really with the goal of just making it easier for people to get involved with soil community science, whether you're totally brand new to the topic and are looking for ways to get started, or are a hardware builder, kind of tech-minded person who's looking for ways to plug in with your skills. So I'm going to show a highlight reel from that review on what tools are out there for communities, and then some of the challenges that also remain. So just a quick note on where we've been posting the resources on the Public Lab website. You'll find the latest posts and also questions and answers, any collaborative wiki pages, and then the contributors, the people who've been working on this topic on our soil tag page. So the URL is at the top there. And we're also going to be posting all the links that are associated with this recording along with the recording on the Public Lab website. So don't worry about trying to copy down URLs now. We'll post it all later. And then where we try to knit all these different materials together with more background information and context for that dialogue on the website is the soil contamination wiki page. And all of the stuff I'm going to talk about today it's on the Public Lab website at those links, and it's open for all to contribute, to add to, and to revise. So we invite everyone to come in and work together on it. And that is at the URL at the top there, publiclab.org/soil. And one of the sections you'll find on that wiki page is some of the very first things that you can do in starting to investigate your soil. So that includes using public records and talking to your neighbors, conversations within your community to find out how that land has been used or is currently being used. And this activity can help you get an idea of what contaminants might be in the soil. So it can help you narrow down what you're looking for if you're planning on doing any further soil testing. There's also an activity for understanding the texture of your soil, which can affect how pollutants behave. And then an activity for hosting a collaborative map drawing workshop. And this is with your neighborhood community. This pairs really well with finding out land uses in the area, and then it can also help you prepare for soil sampling plans if you do plan to do further soil testing. So say you have some idea of what contaminants might be in your soil, and you know you want to do some kind of soil testing. What are the tools and methods that are currently out there for testing soil for contaminants? So we've organized the information both on this presentation and on the Public Lab website in like a very simplified manner. And really that's just organizing by overall purpose. And it's not a perfect way to delineate things. It's definitely oversimplifying, but it's getting at one of the pieces of planning for or designing a study for looking at your soil. And that's sort of like, what's your goal? Are you looking for sort of like screening purposes, or are you looking to use the data for some sort of enforcement or some sort of legal case? So methods for screening purposes, very much in general, are generally easier to use, and they're often designed to be portable. They tend to be lower cost, but the trade-off there being data precision and accuracy. And this is relative to lab-based, more conventional methods, and also certified methods that require often specialized training to use specialized equipment in the lab, and can cost more, especially when several tests are required, but they produce generally the most accurate and precise data. So again, the goals differing here sort of being like, are you looking for like awareness raising or doing some initial investigation to see if you need more extensive testing, or are you going straight to like getting the most precise data because you're looking for using the data to submit to agencies or in court, for instance. So in the screening category, I wanted to highlight a couple tools in both of those categories, but in the screening category, there's a lot of sort of inexpensive test kits out there, often designed to be used in the field. And the ones that I'm highlighting here involve mixing soil with prepackaged chemicals or reagents and shaking them up and then observing color changes to indicate the presence and the amount of contaminants. So some examples, the chlorine soil PCB screening kit, that's for polychlorinated biphenyls. Those are contaminants associated with like like electrical and construction activities. The kit is commercially available and comes to about less than $25 US per test. Nuestros Suelos is a toolkit for participative assessment of soil degradation. This was developed by Public Lab community member Sebastian, who's on the call today, and tests for heavy metals, copper and arsenic, as well as indicators of soil fertility. There's also a field test for lead that was developed by Landis and colleagues, and it comes out to less than $5 per test. So those latter two kits that I mentioned here, they're not generally widely commercially available yet, but there is work currently going on to make those more available to people. Higher in price in that screening category still are a couple of commercial kits that are more widely available and also portable. And their price generally makes them less accessible to individuals, we found, but community groups can potentially invest together in these. So one of those is the Hanby field test kit. This is for detecting petroleum hydrocarbons like diesel, crude oil, motor oil, PCBs and other petroleum products. It also involves mixing reagents with soil samples and then observing color changes. The cost is $1,300 US for with materials for about 15 tests. And then the X-ray fluorescence spectrometer, XRF, detects metals, heavy metals like lead, arsenic, and copper And it does this by shooting X-rays at a soil sample and then measuring the energy that's emitted back by the particular elements or the metals in the sample. And these are pretty widely used. There are lots of different options out there created by different companies. They're pretty expensive at $31,000 to buy. They can be cheaper to buy used, about $8,000, or to rent. Many places also rent them at about an average of $600 a day. So all those soil testing methods I've mentioned so far, which are just a few examples, are ways to measure the amounts of contaminants in the soil. But the amount of contaminant in the soil doesn't always translate into like a predictable effect on living things. So another approach that some people are using to complement more conventional testing is to do tests for toxicity, or what are termed like effect-based tests, to measure like impacts on living things from contaminated soil. So one approach is a bioassay, and this means using plants and other living things to measure the effects of environmental pollution. So for soil, one approach is the lettuce seed bioassay. And I really like this one because it's quite accessible. You buy a pack of lettuce seeds, expose them to contaminated and non-contaminated soil, and observe differences in how many seeds sprout, germinate, and then how long the roots grow. So this is a procedure that has been standardized. EPA has recommendations on it, and there's lots of scientific literature on it as well. So what the expected outcome here is that contaminants can stunt the growth or prevent sprouting. And it costs about less than $20 for a pack of seeds and some filter paper and distilled water. And there's protocols online for how to do this. And then we've linked those on the public lab website as well. Then there's also one for the DIY biologists out there. There's a bioluminescence inhibition assay. And this uses glowing aquatic bacteria, so bioluminescent bacteria, to test for the toxicity in a soil sample. And pollutants tend to dim the bacteria's glow, which can then be measured with a photometer. So this method, again, is widely used in research labs, but there's for sure potential for DIYing here. So culturing the bacteria, extracting the pollutants from the soil sample, and then using like a simple open source photometer to measure light output. And I see, yeah, so awesome. Mimi's got some links in here about potential use. So we'll share those links out with the call as well. So in that other category, the lab-based or certified methods, going the lab testing routes, this involves collecting soil samples from your site and then mailing them to a lab. So they'll typically use more conventional methods to identify and measure contaminants in the soil sample. Some labs are certified for certain methods while others are not. So if that's something that you're interested in for your goals, then that's something to ask the lab. The cost varies a lot depending on what method the lab is using, and then what kinds of contaminants you're testing for. So it ranges from $30 to $300 for heavy metals and organics, and that's per sample. So it can get pretty expensive if you're testing multiple samples. On the public lab website, there's several places to learn and talk about soil sampling. You can see some of the example pages there, and includes resources on how and where to sample, and then also on interpreting soil test results. Later today, at 10 a.m. Pacific time, 1 p.m. Eastern, our friends at Citizen Science Community Resources are going to be giving an introduction to their soil sampling toolkit that contains all the materials and information you need to do soil sampling and lab testing, with support for interpreting results as well. Okay, finally, before we take a pause, for those of you who want more details or to add information on soil testing that you have experience with or know about, there is a collaborative spreadsheet that anyone can view and edit. So there's information on cost there, on expected precision, what's the scientific concept or method behind the tool, and then also a lot more information on where to get, where to acquire these tools. So please go ahead, view it, edit it if you have something to add. It's there for everyone to use. Okay, so let's take a breather again, and return to the question we reflected on at the beginning of the call. So when you hear the word or the term soil contamination, what do you think of? And if there's any new thoughts or questions that come up, please feel free to enter them into the chat again. And we'll soon be turning the call over to a more dedicated time for reflection and discussion. I just wanted to take another moment to pause here before I finish up with a few more slides. So let's just take a minute to reflect. Okay, so another thing that I'd mentioned earlier in the call that can come up for folks is soil remediation. So what is there to do after you find out that there is soil contamination, and what options are there for remediation or cleaning up the soil? So technical remediation methods can be paired with community advocacy, to bring public agencies in with their tools and resources like funding to do cleanups in communities. But we've rounded up some of the methods and dialogue on tools here on a couple pages on Public Lab. Specifically, there's a wiki page on soil remediation. So just to go over some of the methods that are there, similar to soil testing methods, cleanup methods vary a lot by cost and accessibility, and depend on what contaminants you might be dealing with. In general, there are different categories that include physical remediation methods. So this is like excavation, so digging up and removing soil, capping it to block access to it, or removing contaminants by heating, like taking the soil out and then heating it up. There's also chemical treatments that bind or stabilize contaminants that break them down into less toxic substances. So this involves like injecting these chemicals into the soil to do that. And also bioremediation methods. So this involves growing plants, fungi, bacteria to reduce soil contamination. And I wanted to highlight bioremediation, specifically phytoremediation, which is using plants grown in polluted soil to reduce contamination, because it's emerging as a more cost-effective approach that uses techniques and tools that are generally more accessible and also align with what folks are already doing if they're growing food in their soil, for instance. So this is using plants' natural abilities to take up chemicals in the soil and help clean it. So in this example, this little schematic, copper and zinc are being taken up by the plant's roots and are incorporated into its leaves. So over several growing seasons, you can then pull out the plants that have taken up these metals and then dispose of them as hazardous waste. So there's a fantastic, so good question, what do you do with the plants? There's a really fantastic fact sheet about bioremediation by the Healing City Soils program that was created by Public Lab community member Danielle. It's also linked on the Public Lab website, and it includes a little, or more than a little, really, like a blurb about what you can do with the material after the plants have taken up heavy metals. And exactly what you do with them kind of depends on the level of contamination that was in the soil, and then might also be in the plants as well. So there's some possibly like a little bit of testing to do on them as well, if you're worried about them being sort of like at the hazardous level. But in general, you don't want to just kind of get rid of them into your like local compost, or your neighborhood, or your residential compost pile, because you might be just putting the contaminants back into the soil. So that collection of methods and tools that I just really sort of briefly mentioned are some of what's available to community scientists now. Sort of in contrast to a topic like air quality, which has really seen an explosion of like low cost open source sensors become available for measuring air quality. There still seems to be a bit of a gap in soil testing between like reliable, really easy DIY methods for detecting soil pollution, and then the lab-based certified methods that are generally less accessible to most folks. But there are people working on this, people on this call, in fact, who are working on this sort of thing. So we know there are research groups and technologists out there who are working on more field tested and reliable methods to detect soil pollution. So we hope that there'll be more updates that we can bring to Public Lab in the coming months and years. So some of the particular areas that we see potential for growth right now are more community accessible, reliable kits for detecting soil contaminants. And this could be potentially adapting tests for water quality, which there generally are more of commercially available, and also developing safe and accessible reagents for doing those sort of like color changing tests. Also breaking down and DIYing those methods for bioassays, particularly that bioluminescence inhibition assay. I think there's the DIY biologists out there who might be interested in culturing the bacteria. There's, I'm sure, already an open source photometer out there, or maybe even a spectrometer that could be used for this. So breaking down the steps there, and then working on developing those pieces so that that particular assay could be something more accessible to folks as well. And then also just more case studies on bioremediation in community. So I know Dan brought up a note here that the timescale for using phytoremediation and other bioremediation methods can be pretty long, and that's true. You do really need several growing seasons, and it is generally better for like low to moderate contamination levels. So this level of details is on the Public Lab website as well. And I would love to see like more conversation around that and sort of tips from folks who have used this before. But it is something that, there are trade-offs there in terms of length of time needed for these different remediation methods, and then also what sort of monitoring needs to go on for the length of time if you're keeping track of, are these methods working? So there are more next step challenges to think of. There are several listed on our soil wiki page. And we invite you to join us continuing this conversation. So you can subscribe to the soil tag at publiclab.org. Post any of your questions or ideas or research notes, projects that you're working on. We would really love everyone to jump into the conversation. You can also talk to people in real time at the drop-in weekly open calls that happen every Tuesday. And again, you can visit publiclab.org/soil to see where all of the resources that we've updated and talked about today are collected in one place. So thanks so much for listening to me present there. I'm going to stop sharing my screen now. And I wanted to turn it over now to the rest of you here. So we could go a full round with a chance for everyone to speak if you want to, and just say sort of what this call has brought up to you, what like what questions you might have, or what ideas you have, or what next steps you think could be done. And if you prefer to just reflect to yourself, no problem, or you can type your reflection in the chat if you're not available to speak at this time. But I think we could go around in the round now, and we could just we have a small enough call. I think we could kind of popcorn around. So I'll start with, I'll just start with reflection, and I learned a lot during these last few months of doing the review, and really just want to express appreciation for everyone who shared their time and questions with us, especially at the beginning of the review, to help sort of guide where it looked like the most interest was and where the challenges were as well. So I'll popcorn it over to Abby, if you don't mind, if you want to share any thoughts you have or questions or thoughts about next steps. That'd be great.
Sure. This was really great. It's just very cool to see all of this coming together. Really liked the presentation a lot. And I'm actually especially excited to dig into the mapping resources that you've compiled. We've been trying to compile some guidance on doing that kind of work as well. So I'm really excited to see what you've got there and how we can use it in our community as well. Yeah, I mean, I just really appreciate having a space to raise questions about all kinds of things and look at all the different possibilities for moving forward on this work. So I'm just happy to be here. Thank you for all the work you're doing. I guess I'm going to hand it off to Dan.
Yeah, I'm also excited to look at the mapping resources for sure. And yeah, just in some of the work that Abby and I have been doing, we've been interviewing some soil scientists. And it seems, just to the point that I raised in the chat about the phytoremediation, for at least for lead, it seemed like most plants don't take lead up, and it would take like many years to reduce the lead level in soil. A lot of the guidance that people gave to us was building and bringing in new soils, and if you're going to be doing gardening, to actually grow above like the existing soil level that has lead in it, and to not expect the using plants more to like stabilize an area, to like hold the soil in place, rather than using the plants to kind of like remove it necessarily. I guess I'll popcorn to Sebastian.
Thanks, Dan. I think thank you everyone for putting this together. I think it's a very good opportunity to have this sort of more open discussions about about issues that are raised when you start dealing with soil. In my experience, I think one of the most challenging things it's trying to deal with the issue of the variability of soil. The matter of how soil in different parts of the world and even in different cities and different small regions are very, very different, and the way you engage with it and the kind of, I don't know, manifestations that pollution have on them, it's very, very variable. I would say that it's much more variable about air pollution and water pollution. So in a way, this is from my perspective has been a main challenge in trying to develop any kind of kit or any kind of methodology to engage and to know a bit about pollution of soils. The issue that you will be forced to adapt the technology, the device, the kit, or the reagents or anything, but like quite constantly, because soils has different things in different places. And this is for me, it's a major issue that, especially when you are doing some sort of a comparative work between different areas that have different kind of soils. So, well, this is more or less my contribution so far, and now I can move to, I don't know where to, let me see, to Mimi or.
Hey y'all, how's it going? Thanks for a fantastic review here. I feel like I've learned so much. You know, I'm most interested, I think, in some of those, you know, last assays that you shared there, Jeanette. I actually have some bioluminescent bacteria in my house because that's a thing that exists here. And I've got soil in my backyard that I have had professionally tested, so I know kind of some of the contaminant levels. So excited to kind of get to play with that and see if I can tell anything with some of I have a couple different photometer options at home. So looking forward to seeing if that does anything. And I didn't even know that that was something that was possible. So thanks. And I am going to popcorn to Christina. Have you gone yet?
No. Hi, everyone. Thank you for hosting this. It's been really great to kind of have a quick understanding also of what options are there, and you know, have the possibility to drill a little bit more into them. I am mostly interested in thinking about ways that those kind of two methods of the kind of the traditional expertise that goes through laboratories could be combined with more citizen science kind of led initiatives, or so ways of collecting samples safely, you know, tips like that, or instructing others of how to do it, and you know, things like how deep do you go, and how much do you clean up the area, how do you select those points. These are things that that are interesting, because if for my kind of purposes it's necessary to prove that there's certain soil contamination, then it might be necessary to use a kind of laboratories, but it might be also not that easy for them to have access to the site. So that's what I'm thinking. I'm thinking along those lines, and I'm interested to hear more from you. I know that there's this other event that might be a bit more illuminating also on that front, but generally I also think it's been really useful, and I'm trying to also think about ways that some of those techniques maybe could also be qualified in terms of how much should we be relying on them versus how much should, you know, how do we kind of what's the margin of errors of each one, and how do we use this in order to make decisions, right? Decisions like if we have to remove certain people from living there, if they're living there, et cetera, and when do we need kind of a different type of verification. So I'm interested in, because I've been trying to kind of read through some of the methodological kind of papers of different geochemists, and there's kind of pros and cons in each method, obviously, but it's just when it comes to citizen science, it's also a little difficult to navigate how much how should we use that information that comes out of it? But I'm really grateful for the compilation and understanding. Thank you.
Is anyone who hasn't spoken yet who'd like to share?
Sorry, I forgot to popcorn.
Oh, no worries.
Should I?
Yeah.
Alana, am I saying this correctly? Sorry if I'm not.
No, you said it right. Thanks. I wanted to ask Jeanette, one of the things that came up whenever you were speaking, I was not aware of that lettuce assay. I think we had mentioned it in passing before, but not realizing, I don't know, I guess the power of that as a means of testing. Did you say that was EPA approved or EPA backed or anything, or did I confuse too?
No, sorry. Yeah, it has EPA standardized, like suggested standardized protocols with like what equipment to use and how to do like quality control and quality assurance. I don't believe it's like EPA certified, and you know, yeah. But there are standardized protocols out there, and there are lots of examples of it being used by different research groups. So there's a good bit of literature backing it, but I don't believe it's like accepted by agencies at this point. The document I saw from the EPA was from like the 70s, so it's been a while. Yeah.
That I thought was really cool though, since most of the time these sort of conversations happen in a citizen science realm. So the fact that there was some higher overarching power that does at least acknowledge these are ways to do soil testing. I thought that was really cool, and I don't know, I was interested in that. I want to learn more about those methods. And then if we're popcorning, I'm going to popcorn to Ashley. I saw you just went off mute for a second.
Yeah, I was just going to jump off of that and just say that mine's just kind of like a more larger topic that's just been thinking about just like how a lot of, at least my limited knowledge in United States, like land management and soil contamination, a lot of that is very kind of like separated or siloed away from like thinking about how it impacts the ocean. And I'm just like curious, like how like soil, yeah, just like what kind of soil contamination like groups are out there are looking at that, and like that larger intersection with like watersheds and or to the ocean and its health, and kind of just thinking about that nexus. That's just something that I'm thinking out loud about. Thanks. And I think Anna, if you maybe want to go ahead and speak. I'm not sure if you abstained from it, because I know Liz did.
I got into the meeting really late, so I didn't even hear what was being discussed. So I honestly don't have any input right now. But I'm really interested in like remediation, and I'm friends with Alana, so I just wanted to hear what was being talked about today.
Thanks, Anna. Yeah, microremediation, we would love to learn more about microremediation too.
Yeah.
So if you have experience with it or find any resources about it, please feel free to share on Public Lab, because I think that's also one of sort of the emerging areas where there could be more.
Cool. Yes.
Thank you.
Yeah, I'm gonna have to ask later on what was talked about, because it seems like it was interesting.
Yeah. So for everyone's information too, we are recording this call, and we'll post it on the Public Lab website later with all of the links that people have shared so far, and then also just a summary of some of the things that have been coming up in this conversation as well. So we'll hopefully have that up on the website soon.
Cool.
So we still have time if other folks want to share any reflections or questions that have been coming up for them.
Can I share some?
Please, yeah.
Want to share yeah. So uses bad water. This company actually ejects their wastewater in some sort of pipes, and they actually uses those water to grow the uh, grow the plants, and they actually sell those to the market. Now, what happened is in every year we got to know that we are having arsenic, many bad elements. Even though I you will never heard of many metals lead are there in vegetables and conditional and condition going worse, and government is not doing anything. And the thing is, actually, there was a research that, let's say that if we eat, if we eat this by 1 year or 1 month, then it can reduce our 1 year of life, or so it is very bad for our condition. But government is not doing anything, and they just actually stop the farmers and people to not actually use bad water, chemical waste, but they don't actually listen to. Uh, so, uh, and actually, there is a problem. Companies that they don't listen to government, they actually do whatever they want. They actually bribe the government, and they inject the water, and the ejected water, chemical waste or bad water used by the farmers, and this causes very has very strange situation. So, uh, can you hear me?
Yeah, your audio was coming through. It was just breaking up a little bit, but thank you, Ashley. I think you summarized it there. But Tax, does what Ashley summarized in the chat there, does that cover what you were saying? We were just trying to catch.
Actually, I'm saying that in India, governments do something, but actually farmers don't do because they want much higher money, and many of the most of the farmers don't have money, and they're actually like actually you also know of the farmer protest in India, and this is still going on in India, and actually we are having the issue, roads are blocked and many others. But the main thing is we are forced to eat those bad vegetables with arsenic, lead, and etc. And we don't know. And there is also one thing we always uh, we always think. So my grandparents and always say that nowadays vegetables are not uh, they're not that good as it was in their time, and they're not actually they don't enjoy the vegetables nowadays because some farmers use artificial technologies to grow and for organic production, and the farmer and other farmers are using wastewater chemical water to produce. So overall, we are not getting natural thing, and of course in taste this is actually weird.
Yeah, that sounds incredibly challenging. Thank you for sharing that story. I think what you bring up is a big challenge that we have also been hearing from other community members, is just like the lack of funding available to do testing on let alone soil, but on things that are grown in the soil that are the things that are going into people's bodies. And then also just lack of accountability with industry, and then also governments who aren't listening to community sourced data. So thanks for sharing that that local concern of yours. For those who haven't had a chance to speak yet, if you want to share anything, we still have a few few minutes so we can keep talking. Simon or Alejo or Matt.
Jeanette, could you remind me the name of the, you said the soil sampling or soil testing kit Sebastian created, I believe?
Yeah, Nuestros Suelos.
Thank you.
Yeah.
Hello?
We can hear
Somebody
you.
hear me?
Yes.
Okay. Well, I have a bit problems with internet and with connection, and it was challenging here about and see what is going on in the presentation. I lost a big part of all the presentation. I'm here because I'm particularly interested in water quality measurements and all the things that Pool Lab can do in this field. But I think that the some problems that are in soil measurements to determine quality and environmental problems are the same for soil and for waters. The problems about some reactions, so about some colorimetric measurements are actually the same. I'm going to see the recording of this presentation, and maybe I could say anything more about all that I'm saying in this moment. But I read in the that some people say that that are initiating, that are a newest in this of public lab, and me too. And I think that the most challenging issue in this kind of initiatives is the achieve a big community of people working in the same thing. And I think that there is a lot of people that are interested and worried about the environmental issues, but achieving a community that do things to fight with these problems is the more challenging issue, or one of the more challenging issues. If there are a lot of people working together against soil pollution, water pollution, air pollution, the technical issues and problems can be solved. And that is all that I want to say for now.
Thanks so much for sharing that, Alejo. Yeah, 100%. I think this was mentioned by other folks who were on the call in previous conversations too. It's like, we know that there are lots of people working on this, and it would be great to know what other groups are out there, and then to share resources too, right? So hopefully we're doing that on this call, and with the work and the resources on Public Lab 2 as a space for that as well. So we're really glad that you're here to contribute to that conversation. So thanks so much for joining. So if anyone else wants to share now, please go ahead. Otherwise, we are reaching the 30-minute, the bottom of the hour here. So very last bit is, I just want to make sure all people are on this call to thank you all again for coming and sharing your time, not just during this call, but for folks who have been joining through the last few months. We've been doing this review, for sharing your reflections here and your questions and ideas. I really appreciated all of the knowledge that folks have shared so far. and what sort of challenges that you're dealing with in your communities as well. So we'll be writing up, like I mentioned, some notes on this call, and then also posting the recording on the Public Lab website. And we hope to see you at the top of the hour for the soil sampling toolkit demo, which is going to be co-hosted with Citizen Science Community Resources. They'll be showing us their soil sampling toolkit. So Christina, this is an example of a community science organization who's combined with that sort of like lab testing technical support piece, so that they're kind of bringing those like oversimplified categories together. Yeah. So thanks everyone for joining, and yeah, hope to see you on Public Lab and at the next event as well, and drop into any open call on Tuesday any week. We'll be there to chat.
Thanks, Jeanette. Thanks, you guys.
Bye.
Thanks, everybody.
Bye.
Take care.
Bye-bye.
Thanks, everybody.
Thank you.
Thank you.
Well, thank you, everybody.
Thank you.
Thanks so much.